Dear students, welcome back to the 6th week class of Advanced Computer Organization and Architecture. Today we will discuss about vector processing principles, vector processor classifications and vector instructions type. Vector is a part of advanced processor technology. So let's know about vector processor or vector processing. Let's know about vector processing. Vector processing performs the arithmetic operations on the large array of integers or floating point number. That means it performs on large number of array where the array elements will be integers or floating point number. Vector processing operates on all the elements of the array in parallel, providing in pass in independent of the other. That means the element operates will parallelly and they are mostly independent. Vector processing avoids the overhead. Overhead means the something extra or extra load of the loop control mechanism that occurs in general purpose computer. To avoid the overhead of processing loops and fasten the computation, some kind of parallelism must be introduced. And the vector processing operates on the entire array in just one operation, and that the operates on elements of the array in parallel. But vector processing is possible only if the operations performed in parallel. At the same time, the element will be independent. Here is an example of vector processing. Look at the figure below and compare the vector processing with the general computer processing. You will notice the difference. Below instructions in both the blocks are set to add two arrays and store the result in the third array. Vector processing adds both the array in parallel but avoiding the use of the loop. In the general processing, there is a loop 10 iterations and read the instructions and decode. Here fetch the element AI and fetch the element BI and after that add the elements of AI and BI and finally store the result in CI and increment I till I equal to 10. On the other hand, if you follow the vector processing, here read instructions and decode, fetch all the 10 elements of A, fetch all the 10 elements of B and finally add the element of A and element of B and that will be stored in the result of array additions in the array of C. So in general processing there is a loop, there is a loop that will be start from 1 and it will be incremented to 10, but in the vector processing there is no loop, so it must be avoid the overload of loop. Here is some necessary terms of vector processing. Let's introduce with those. At first, the single instructions multiple data. So what is that? In operating on multiple data in just one instruction, that means it will be operate in multiple data, but in the one instruction is also called single instructions multiple data, or they are also termed as vector instructions. Now the data for vector instructions are stored in vector register. That means the data of vector instructions will be stored in vector registers. In vector register is capable of storing several data elements at a time. These several data elements in a vector register is termed as a vector operand. That means the elements that will be stored in vector registers is known as vector operand. So if there are n number of elements in a vector operand, then n is the length of the vector. Characteristics of vector processing. Each element of the vector operand is a scalar quantity which can either be an integer, floating point number, logical value or a character. Below we have classified the vector instructions in 4 types, where O1 is V indicate V, O2 is V indicate S, in O3 V scalar V indicate V, and finally in O4, V scalar of S indicate V. Here V is representing the vector operands and A represent the scalar operands. In the figure, O1 and O2 are the unary operations and O3 and O4 are the binary operations. Now let's know about the classification of vector processor. According to from where the operands are retrieved in a vector processor, pipelined vector computers are classified into two architectural configuration. One is memory to memory architecture and another is register to register architecture. So let's introduce about memory to memory architecture. In memory to memory architecture, source operands, intermediate and final results are retrieved, that means read directly from the main memory. For memory to memory vector instructions, the informations of the base address, the offset, the increment and the vector length must be specified in order to enable stream of data transfer between the main memory and pipelines. The processors like TIASC, CDC, Star 100 and Cyber 205 have vector instructions in memory to memory format. The main points about memory to memory architectures are: first one, there is no limitation of size, and the second one is speed is comparatively slow in the architecture. And then the register to register architecture of vector processor. In register to register architecture, operands and results are retrieved indirectly from the main memory. That means memory to memory is retrieved directly from main memory, but in register to register architecture, there you can see the result or operands will be retrieved indirectly from the main memory through the use of large number of vector registers or scalar registers. The processors like carry 1 and the registers VP200 use vector instructions in register to register formats. The main points about register to register architecture are: the first one, register to register architecture has limited size. That means memory has no limitation of size, but register to register architecture has limited size. The second one is speed is very high as compared to the memory to memory architecture, and the third one is the hardware cost is high in this architecture. Here is a block diagram of a modern multiple pipeline vector computer. If you follow the figure, you can see in the left side is mentioned a high speed main memory, and it is connected with two units. The first one is instruction processing unit, and another one is the vector access controller, and it go through the scalar processor and vector processor in two ways. Instruction processing unit can go through the scalar processor directly with a scalar by scalar register, but it can go through the vector processor indirectly, and that will be at first go to the vector instructions controller and then go to the vector processor. At the similar way, vector access controller also go through the scalar processor and vector processors. Let's know about the vector instructions type. Most vector or SIMD means single instructions multiple data multimedia extensions. Instructions have 3 or 4 128-bit vector operands, 2 or 3 source operands and 1 result. Also, most instructions are single instructions multiple data in nature. The instructions have been chosen for their utility in digital signal processing algorithms, including 3D graphics. The vector has following types. The first one is vector integer instructions. In these types, this includes vector arithmetic, compare, logical, rotate and shift instructions. They operate on byte, half word or word vector elements. And the second one is vector floating point instructions. This includes floating point arithmetic, multiply or add, rounding and conversions, compare and estimate instructions. They operate on single precision floating point vector elements. The third one is vector load and store instructions. This includes only basic integer and floating point load and store instructions. No update form of the load and store instructions are provided. They operate on 120-bit vectors. The fourth one of vector instruction types is vector permutation and formatting instructions. This includes vector pack, unpack, merge, slurt, permute, select and shift instructions. The fifth one is processor control instructions, and this includes instructions that read and write the vector status and control register. The final one of vector instruction types is memory control instructions. These include instructions for managing cache, that means the user level cache and the supervisor level cache, and these instructions are no operands. The special note here is the most of the vector instructions are pipelined, as vector instructions perform the same operations on the different data set repeatedly. Now the pipelining has startup delay, so longer vector would perform better here. Thank you. That's all for today. Stay tuned for the next class.